All right, welcome. So we're gonna talk about tidyverse today for this part of the workshop. I had my markdown pulled up for tidyverse. All right, cool. So what's tidyverse? You're gonna when you're doing R, you're gonna hear tidyverse a lot. Whether you go to Stack Overflow, Stack Exchange, even generally learning coding. This is kind of like a basic package that people start with when they're learning R, aside from just like the base function inside R. And personally, I can do most of the things I ever need in tidyverse. I mean, to deal with like time and stuff, you'll have to use looper_date, which I included the cheat sheet on my website, but I didn't plan on making a workshop out of it. But most of the time, you should be able to achieve most of the stuff you want to do just using functions and packages from tidyverse. Tidyverse itself includes, I think, 8 packages. There's readr, which you've been using to read CSV files. There is purr, which I won't go into it. There is tidyr, and there's dplyr, which is the main focus of this workshop. Is for you to like data manipulation. And you can see kind of like the list of tidyverse packages when you actually load your package. You'll actually see it happen. Anyway, so if you haven't installed your package, haven't installed tidyverse, you can run this code, install the packages with a string tidyverse, and load it into your, and then you can load it into your session with required tidyverse or library tidyverse, or whatever you choose. Doesn't really make a difference at this point. Anyways, and today the data we'll be using will be a subset of the data that we've been kind of using from the surveys that we collected to sign up for this workshop. You can read that data link in using this link. Cool. Also, everyone has access to like my website, right? So you have access to this right now. You can read this if you want. All right, cool. So the first thing I want to talk about in tidyverse is this pipe operator that allows you to write your code a lot cleaner, a lot more concise. So this is like a really powerful tool. And if you're familiar with shell, which I don't really expect people to be, if you're familiar with shell, this is exactly what the shell pipe operator does, which is like a straight line. So to kind of tell you why pipe operator is awesome, and now I just call it pipe. I give you an example here. So say I have an original data set called data, right? And I run it in the function f1. Then I can, and the output would be could be like another data frame, assuming that it's a data frame. Then I can insert, what's the word? Save. I can save this data frame in a new data frame called data1. Then I can run another function with data1, and I can save this data frame as data2. I can keep doing the same thing, data2 in f3, and I can get data3. And I can do a fourth function and call it data final. Okay, so if you just look at it at a glance, it seems pretty clean because you have a very clear logic of how this line is working, right? But over time, you're gonna get tired of rewriting these things. Keep writing data1, data2, data3, data4. It gets tiring. And also it makes your workspace really cluttered because you end up having all these intermediate files that you really don't need. So the way to solve that problem to make your code cleaner is using pipe. So how do you use pipe? What pipe does is takes a function of the output of your function, and then it directly feeds into the next function you want to use it for. Right? So it saves you this intermediate process of having to save that data frame first or save that object first. Okay. So this is what that would look like. We would say, oh, we want to save a data file called data final, a data frame called data final. And what data final is going to consist of is this original data. And I'm going to pipe this data into the function f1. The f1 is going to have an output, and it's going to be piped into the function f2. And we go on to f3, and you go on to f4. And this becomes your data final. And this operation is almost exactly the same as this one, except in this one, you have all this intermediate file, but in this one, you just have data final. Okay, so pipe makes things very clear. It makes it a lot more concise, so your workspace is not all cluttered. And also, like when you're like doing this kind of thing, it looks a lot more like step by step than just like individual lines of code. So I personally think that's a lot cleaner and easier to use. Sometimes if you have like multiple pipes, you can just comment out one line or two line to stop that step. Skip over that step, and it still pipes onto other lines. So it really gives you this really clear anatomy of the code that you wrote. So I think that's like really useful. I personally use it a lot. Most people I know that uses pipe a lot as well. Cool. So this is kind of like just like my philosophy. I put every function call on its own line, so I know where I can change things if I need to change anything with the pipes or with the code line. For the rest of this specific workshop on tidyverse, I'll be focusing on the package dplyr, and I'll talk a little bit about tidyr with like a couple functions from there. So technically, you can totally do most of the data analysis you need with just the tidyverse package, because, well, technically it included 8 packages, but it's good enough for most of the things you would need. All right. So first I want to talk about dplyr. And when you're doing dplyr, or if you want to know more about dplyr, I included a link here. It's also the same link in the lecture notes. You can look at their vignettes from their own website. But I'm going to talk about a couple of functions that I personally use the most and find most useful. So the first function I want to talk about is the filter function. A filter function is literally a filter, so you can get a subset of data that fits a certain condition for you. So filter has two arguments. It has the data frame that you want to use, df, and it has a truth condition. What do you mean by truth condition? Filter will only output the data frame where the observation is true based on the condition you put in. Okay, so when you're thinking of filter, yes, most people think about it as, oh, I want these things to happen, but what you really should think about is what are the circumstances where this truth condition will be met? What are the circumstances where I'll write a logical condition and that logical output is true instead of false, right? What that also means is you can write a condition, but if that condition is what you don't want, you can add an exclamation mark before it, and you can negate it. All right. If you want to read back onto like logical conditions, you can go back to the first workshop in What is R, where I talk more in depth about logical values and how to write conditions. But this is what you would do. You say, I run a function filter. I have my data frame called data, and then I have this truth condition, which means this filter function would output a data frame that matches either this condition or this condition. Okay, and I know this looks messy. I specifically wrote it so you can see that it can be very complicated if you want it to be. So making your filter condition clear and readable or legible is very, very important. Okay, so when you're writing these code, it's super important that your code is actually legible to yourself so you don't get confused. Personally, a couple times I was dealing with my data, I accidentally filtered it the way I don't want instead of the way I want, and my data came out really weird, and I could not figure out why for the longest time until I checked my filter truth condition, and I realized I was supposed to negate it, and I forgot to. So it's important that you write your truth condition correctly. Okay, so this is an example from our data, and I'll load this data now so we can use it. All right, great, my console. Okay, so for this data, right now I have my data set, and you can glimpse it. I only took a subset just for kind of readability. So let's glimpse this data and look at what this data frame looks like. Okay, so this data frame that I gave you has 6 variables. It has a variable workshop, that is like the answer of people's answer to whether they want to attend the workshop. It has people's age, it has the county that people put in, it has what people think the social committee's name is, it has everyone's cohort, and GPA data. This is completely simulated, all right? So this is not your actual GPA, I just simulated it. Okay, so I have these like 6 variables. Okay, if I run filter and I say I set my truth condition to be workshop equal maybe. That means this data frame, even though you can see here, there's yes, there's maybe, there's no's. After I run this, I will only get observations where their answer to the workshop value is maybe. I won't get anything else. Right? So I'm literally getting a subset of the data. What this also means is I can do more than just this, right? Technically, I can say, let me find my code. I can run multiple variables. If I want workshop to be maybe, and I want the GPA to be above, say, 3.5, right? Then when I do this filter, what it gives me is this data frame. I can't see it fully because of my computer. What you get is this data frame where all the workshops are maybe, and the GPAs are strictly above 3.5. Right? Here you can see some GPAs are like 3.1, and it could be lower. But I can do multiple variables in my truth condition, and it will only output the ones that fit. Right? You can clearly see this table has 240 observation, while this table only has 128. That's where this filter is doing. All right. The next function I'll talk about is arrange. So what arrange does, and actually like most of the functions you can find in tidyverse are very self-explanatory just by its name. That's a very good, I guess, convention or practice, a naming practice, is to name your function in a way that is easy to understand from the get-go, instead of having to read through documentation. So what does arrange do? Arrange lets you arrange your data frame in a certain order, either ascendingly or descendingly. So I can arrange this data frame by age, and then you'll see this being arranged, in the order of the age. You can do it either ascendingly by default, or you can wrap your variable. You can wrap your variable with the function desc, DSC, which just means descending, and you'll arrange it descendingly. Now, arrange does come with a priority order. Whatever order you put in here, whatever order you put in the call, you can see the arguments are your data frame and then just variables that you want to arrange it by. But by the order that you put in your variables argument, that's the priority it will set to arrange your data frame for you, right? And this is, I guess this is really useful when you're trying to see like extreme values in your data frame. Maybe you think, oh, there might be a data entry error somewhere and I need to find it, right? You can arrange it either descendingly or ascendingly, and then you can use head to see what variables are being weird and what observations are being weird, and you can tell like whether it's a data entry error, coding error, like why that thing is popping up. Okay, so this is an example. If I take data and I pipe it into arrange, and I say I want you to arrange by as.factor cohort, so I want you to arrange by the factorized cohort. Right, remember in R 4.0.1, strings are not factors by default, right? So if you want to order strings by alphabetical order, you want to make sure that they are a factor. So you have kind of like a inherent order. So I say, okay, I want to order the cohorts alphabetically, and then I want to order their GPA descendingly. So the highest GPA on top, going down, but it prioritize cohort first. Right, so what you will see here is this table where cohorts are organized by alphabetical order, and then GPA is descending. Any questions so far? Okay, I would like to think it's like fairly self-explanatory. Wait, I didn't realize in didn't come out. Oops. Yeah, I missed this part. My bad. Let me cut it the slide so it works the next time I run it. Okay, so this is a good time for you to like see how I deploy this website. You'll also be able to see it next week when I talk about our markdown automation. So basically I have this markdown written. So I'll just click knit, and that this specific markdown file produces the slides that we're using. Or not. Oh, it's not using it. Oh, it's because I'm on the wrong file. Where's in? There we go. So this file produces the slides that we're using, right? And what I have is a repository in GitHub, and it's connected to my computer. So when I update my files, it changes the files in my local repository. And then I just need to commit this change onto GitHub. So GitHub takes in the new file, and I can give it a random commit name like slide correction. So what we're doing right now is it's a common thing called version control method or version control tools. So basically, every time I publish to GitHub, I give a summary of what this commit is. So then when I go to GitHub, I can look at the history of my commits and know like what changes happened at what time and kind of like what the change was for, so I can better control for the version I'm using. So this is just like a, I guess, preview of what we're going to talk about next week. Okay, so now that's fixed. It usually takes about like 3 to 5 minutes for GitHub to fix it, so I won't worry about that right now. Okay, but what I missed is I wanted to talk about this in operator. So in isn't really used that much unless you're using filter and you need like a whole thing or a whole category of things to use. Okay. So what does in do? In is kind of like you're writing an or condition in filter. Or I mean, I guess in anything that requires you to do some sort of a truth condition. So in is just doing or, but instead of saying this, so A or B, you can say I want this thing to be in this vector, right? So what this does is, I can write this file. Okay, this way you'll be able to see better. Okay, so normally if I want the social committee name to be either Sucksack, which is the wrong spelling, or Vanessa, which is the just like a kind of like a troll that I did, and many people actually chose it, so I thought that was hilarious. Okay, so normally my truth condition needs to be social equal Sucksack. Okay, and how do I complete this? Anyone? What do I do? If I want it to be either social equals Sucksack or equals Vanessa, how would I write this truth condition? Were you trying to talk, Mac?
Would you use the upwards line to say or?
Right, so I'll use my or operator, right? Or qualifier. Actually, I think it's called qualifier. Maybe qualifier. I'm not really sure. It has a word for it. Not really good at it. Okay, so I'll say or. What else do I say? Or is this good enough?
No. You should say or social equal to Vanessa.
Exactly. Or social equals Vanessa. I need to say this to have a complete condition, right? Because this is one condition, this is one condition, and I connect them by the or operator. Right. So when I do that, what you'll see is social will only include the wrong spelling of Sucksack and Vanessa. Okay. But a cleaner way or a shorter way, not by much, but a shorter way to do this is to say I want social to be in Sucksack or Vanessa. And you'll see when I run this code, it gives you the exact same output. It filters the exact same way. This is just an easier way to write social. Okay, why do you need to do this? Well, if I have many values in social, right? Say like in this county one, there's many different counties that people submitted, then it would be inefficient for me to write county equal this or county equal this and do it many times. Rather, what I can do is to say, unique. So I'll just use like an example kind of on the spot here. So these are the unique counties that people selected, okay? And then say I only want to randomly pick, how long is this thing? 21, 22, 23, 24. Okay, 1 to 24. Say I want to randomly pick 6 of them to use. Okay, so these are the, I don't want NA. Okay, so say these are the counties I picked here, right? I'll just save this as a vector. Okay, so this is what I have selected. It's a vector called selection. Okay, I could technically say I want socials to equals to Hyde Park, Illinois, or social equals to Cook, Illinois, or social equals to, you get the point. I can write it all out, or I can just say social in this selection vector. It's not social. County in this selection vector, and then it gives me only counties of that vector. Okay. Does that example make sense? All right, yep. Cool. Thanks, Hal. All right, I'll deal with that later. Okay, by this point, I think my repo is done. So let me redo this. All right. Skip through it. Okay, yeah, so I was talking about in, right? You already saw kind of like the example of what was supposed to happen. And we talked about arrange, and I'll show you the example of arrange. Okay. So I can arrange by the social committee, and then, arrange by cohort, and then descendingly GPA, right? And you can kind of see my kind of choice of code here. I can either, put it in separate lines, or I can put it in the same line, right? I can totally easily just have written like this, and that would have been fine. Whether you decide to separate it to the next line or not is really a personal choice. Usually I only do it when my line is too long, it's getting cluttered up. Then I separate my conditions or like what I'm trying to do into different lines. It's really a personal choice. Whatever makes it more readable for you, that's what's most important. All right, continue on. All right, this is probably one of the most useful function. It's called mutate. And it's also like the only function that's not like very intuitive in terms of naming, even though like after you really understand what it's doing, it becomes a little more intuitive. So normally, like when you think of the word mutate, you think of like, oh, there's a change happening within, okay? But what the mutate function does is more than just change. It can also add things, right? It can take away things, but it can add things, or it can change. It can make changes, right? So the mutate call is your data frame, and then you'll have your variables. And what do I mean by that? What it does is mutate takes in your data frame, and then it adds variables if the variable doesn't already exist in the data frame you specified. If the variable already exists, it replaces it, right? So it does like an internal change, right? So here I have an example of data. I also saved it in data, but I was just like, I saved it in data so we can continue using it. But here I said, all right, I have my data frame data. I want to pipe it into the mutate function. Inside mutate, I want to create a new variable called grade age, which is just GPA times their age. And I have grade random, which is GPA times a random number between 10 and 20 that I just sampled, just a random number. Okay, so then I get something out. Yeah, I'm not sure really why this data frame didn't save and then be shown, but that was what I was trying to do. Right, so, oh, it's because I set eval to false. That would be why. Okay, because then you just save it. I'll change this to echo. Okay. Now the next time I run this junk, it'll save. Okay, but this is what I was doing. So then you can see I have, that's not a very good way of seeing it. Cleanse data. Okay, so now I have this, and you can see I have a new variable called grade age and grade rand, and it's just this multiplication based on the operation I did here. All right, so if you instead want to change the variable you already have, say I want to change, the GPA from having the 7 digits to just being rounded up to the original digit. I can say data mutate GPA, which is my original variable, to be equal to round, which rounds up your number, GPA. So now you can see GPA is just a number instead of, it's like an integer instead of a numeric double, even though it's still treated as double, by the way. So there. Okay, so does that kind of make sense how mutate works? All right, and we can continue on. So similar to mutate is summarize, but the biggest difference between summarize and mutate is in mutate, you get to keep your original data frame. In summarize, you lose your original data frame, right? You can group it and pick the variables you want, but you'll only get what you put into it. You won't get your original data frame back. You can see I have the data frame data, and I say, all right, summarize, like I call the function summarize, and I want it to be 3 variables. I want it to have average GPA, which is the mean of GPA. I want the max GPA, so max of GPA. I want the sigma GPA, which is the standard deviation of GPA. So I call SDGPA. So what I get out, instead of the original table, like what mutate would give me, when I use summarize, it gives me a summary table of the things I was trying to do, of the things I was trying to see. Right, so this is a really good way for you to calculate means and stuff if you just want like a really small summary statistics data frame to look at for specific variables. Now, if you just have one variable to look at and you want to know what's going on with it, I wouldn't recommend using summarize. What I would recommend using is a function called summary, and then you can just put a variable in. Say I want to look at age, and it summarizes it for me. Or if you want to look at a summary of all your variables, you can just say summary and put in your data frame. You actually end up with summary on all of the variables. So that's one way for you to use this. Typically, you would only use summarize if you need if you specifically need to produce a new data frame, whether it's for graphing or things like that. If you're familiar with data, summarize is how you would what you would use to collapse your data into a larger level. Okay, so that's summarize. Pretty useful stuff. All right, the next thing I want to talk about is group by. Group by is very seldom learned correctly in the sense that like people kind of know what it is, but they don't really use it to the best advantage that it has. And I personally think group by is super, super powerful, perhaps at the level of mutate in terms of data science, where you're trying to add stuff. If you are familiar with SQL or sometimes people call SQL, group by is also something you will use in a SQL call when you're accessing a database. If you're not familiar with SQL, just ignore what I just said. Anyway, so what group by does is it takes in your data frame and it takes in the variables you want to group this data frame by. Okay. Now, when you just run group by, it doesn't do anything practical to the data in terms of operations, or I guess in terms of actual changes. The only thing is it imposes a grouping structure onto your data frame so that all of your operations are done by the groups that you specify, right? So say I'm looking at my data frame data. If I want to do all of my operations by cohort, right? If I want to find the average GPA of cohort, if I want to find the average age of a cohort, I would say data, pipe it into group by cohort. Then anything I do from then on, whether it's mutate or summarize, it will be done by group, right? So then I can actually get like GPA by group, age by groups, things like that. Okay, so I can show you an example here. If I say data, I want it to be group by cohort. Okay, you can see my data still looks the same, except here R tells me, oh, you have groups that are constructed by cohort, and there are 7 total groups. Then if I say I want to summarize the average GPA, average GPA equals to mean GPA, then instead of having, remember how I have this just one line of everybody's average? Instead of having that, what should I have now?
Like the average for every group.
Exactly. I will get the average GPA for every group, right? And you can do group by for even more variables, right? I can group by whether people want to attend workshop in their cohort. Then I get some people that said maybe, some people that said yes, and their average GPAs. Okay, so you can tell from here, hopefully you can tell from here that group by is super, super powerful. It's a very powerful function that often gets kind of like neglected in a sense.
Yeah.
Okay, but with great power comes great responsibility. And I know that sounds really cheesy. But what I mean by that is when you impose a grouping structure, everything that's going to happen to your data frame is by group, which means if all of a sudden you don't want to have that group now, but you forget to take away the grouping structure, you're going to end up with something horribly wrong. And that happens way more often than you would imagine. That happens a lot. Like half the times when I go onto Reddit, where the subreddit R language, and I look at people's problems, half the times it's literally just somebody's kept the grouping structure, they forgot to take it away, and they ended up with this like really weird data frame because they had the wrong grouping structure. Okay, so how do I redo this grouping structure? There are 2 ways, and they're both kind of overriding it. So the first way to override a grouping structure is to give it a new grouping structure. So instead of workshop cohort, I can regroup it by, I can do group by cohort, and it only uses cohort to group instead of workshop cohort. I override the grouping structure. The other way to do it is to take it away using the function ungroup. This little guy right here, ungroup. So here you can see I group my data by cohort, and then I mutate it to get the average age of each group, each cohort, right? This is what I'm doing. I already grouped it by cohort. So when I do mutate, I get the average age of cohort. This is a small thing, but it comes up a lot actually. When you're doing mean or sum, things like that, when you're doing a mutate call, sometimes you might have NAs in your data, right? NAs happen all the time. Now remember, when we have NAs with an operation on anyone else only gives you NA. Which means if I take the mean of a data frame or of a variable that has NAs in it, I'm just gonna get out NA. The way to circumvent that issue is to add an argument called na.rm equals to true, where it excludes the NA observation from the calculation. Right? So I mutate a mu age, which is like the average of age, per cohort and ignoring NAs. Now I'm gonna ungroup this data. So I take away the grouping structure and I mutate it again, and I can get a new thing called group difference, which is the average of age of everyone. So the average age of the entire data set minus the average age by cohort that I already got before. Okay. So you can kind of imagine what that would look like is this. All right, this is kind of like a sample just for you to look at. So by cohort, I have these age average per cohort, right? And then I have this group difference, which tells me the average age of everyone minus this age, and then we can get the average. So you can, if you want, you kind of do the math here. Is okay, mu age is 26.1, group difference here is 0.26. So if you add these two up, that means that everyone's average should be 26.36. Okay, is that right? 26.36 minus 26.9 is negative 5 something. I mean, there's some roundings that happen here, so you know you can kind of ignore it. But basically, that's how you would use like a grouping structure. Make sure you ungroup it. Okay. Now there's a bonus I want to tell you guys. I just learned about this year when I was doing the geocoding. If you're ever doing geocoding where you have to calculate the distance between 2 points, make sure you use row-wise. What row-wise does is it makes every single observation its own group. So like if you do mean, it literally just gives you whatever it was before because it's its own group. So the average is the own observation value. Make sure you do row-wise if you're doing geocoding, or sometimes if your code is just not coming out correctly and you just could not realize why, try row-wise and maybe it'll work just because of your, maybe like sometimes your logic is not working in the tidyverse framework. And doing that could help you with actually mutating it by the data frame itself. But row-wise is also a grouping structure. So after you use row-wise, finish your operation, make sure you do ungroup. I was writing a set of code, I can't remember what it was for, but I was writing something where I used row-wise and I forgot to ungroup. So all of the subsequent operations were row-wise and things were not coming out correctly, and I was really confused. And after like literally hours, and then I realized row-wise was a grouping structure, so I had to ungroup it. Yeah. Cool. Moving on. The select function and the rename function. Quite literally, select lets you select columns from a data frame, right? It takes in your data frame and it takes in the columns you want to select. Rename doesn't select your variable, it lets you rename the variable. Now this order is something you want to remember because depending on the language you're using, this order can be switched. In R is new, old, right? In Stata is rename the old variable, the new variable name, yep. But in R it's like the flip of it, which is really weird. So new call, old call. Okay, the difference is select picks specific columns. Rename gives you the original data frame just with the names changed. Now, if you just want to change, if you want to select things and rename things at the same time, you don't have to call select and rename subsequently. You can call select and use new column equals old column to rename that new column you just selected. Okay, like I said here, new var1 equals old var1. Okay, so that's select. One more thing, or actually, I guess 2 more things. Say all you're trying to do is reorder your data frame, right? For example, remember our data frame here is workshop, age, county, blah, blah. Say I want age, say I want cohort to go first. What I would do is data, I pipe it into the function select. I want to select first the cohort function, the cohort column. So now cohort is going to come first. But right now, if I run this, what would I get?
You only select the cohort.
Right, I'll only get one column, right? I'll only get cohort. So what I can do is everything. And it gives me everything else. So it lets you reorder the columns. Now there's a lot more like sub functions, little functions like everything in tidyverse. You can explore it. I don't typically do reordering, just there's not really a point for you to do it when I'm just modeling things. But it could be useful if you want to print a table specifically in a way that you want. Okay. So that's kind of select with everything. Oh, and if you instead of picking a column, you want to delete a column, you just need to add a negative sign to the column name, right? So if I say data, I don't want the column grade age anymore, I can say data select minus grade age. So that gives you a new data frame where grade age is gone, right? There's grade age here. After I selected it away, grade age is gone. Make sense?
Yep.
All right, cool. So this is kind of like the example I was doing, right? When I'm selecting things, if I give it a new name, I say participate equals workshop, and I also want GPA and age, then I get a column called participate instead of being called workshop, it's now called participate, and there's GPA and there's age. Right? I'm selecting this subset of a data frame. Right. So one way to kind of think about this is select is kind of like the other version of filter, right? When you're filtering, you're matching the conditions horizontally. You're matching your observations. When you're doing select, you're matching the conditions vertically, which is just selecting the variables. If that makes sense. Hopefully it does. Cool. All right. This is a function that's really cool. Sometimes it's useful, but it's not used that much. So you might forget about it and you have to look it up. But it's also very self-explanatory. It's just called distinct. What it does is it takes in your data frame, and then you give it some columns that you want to distinct, and then what it outputs is distinct values of those columns. If you have multiple columns, it gives you the distinct combinations, right? Like we can tell here, there's a lot of duplicates, but when I do distinct workshop cohort, which means I want distinct combinations of workshop and cohort, and then I can arrange it by cohort, then I can see, distinct combinations. Yes, anthropology, maybe anthropology. Yes, economics, maybe economics. Things like that. I get this distinct combination of what's going on, right? But if I were to just say distinct distinct workshop, right? Pipe data into distinct workshop. Oops. All I would get is yes and maybe, right? Instead of all these distinct combinations. So this comes out to be useful when you need to kind of simplify your data in the process of doing things. Especially if you're writing a function that has a lot of duplicates and it's taking a really long time to run when you're doing a relational data set, which we're not going to talk about. But if you're doing a relational data set, sometimes you need to simplify it to be able to merge back in easily. Just keep this function in your back pocket. Sometimes it might come up and you'll be like, oh, wait, I know this function. Great, I can use it. All right. So that was all of dplyr that I wanted to talk about. Obviously, there's more functions in dplyr like left join, right join, inner join, and other stuff that you can do, but I'm not going to go over it right now. Do you guys have any questions about dplyr?
I have one question about group. Like, can we group
Yes.
by and then like draw graphs according to different group?
Yes, but what you would do is, remember this grouping structure doesn't really translate into the ggplot framework, but what you can do is to impose this grouping variable as a factor into either the facet or any aesthetic, right? If I have groups by cohort, even without the grouping structure, I can still say in ggplot, color equals a cohort, then my graph will be by the cohort. Yeah, good question though. Anything else before we go to tidyr?
I have one.
Yes.
I don't know if it's too specific to me, but so for my thesis, I had a few columns, like it was 75 columns somewhere in my data set that I wanted to filter out any values within those columns that said NA, but not everything in the data set that said NA. And I didn't know how to just select those columns, and if there was a way to get like, I don't know, column 3 through 86, and then filter just in those, but still have the data set.
So, okay, when you say filter, are you trying to do it by row or by column?
By column, or actually no, by row. So any row that has an NA within those variables,
do you want to
I would want
delete
to
the row?
out. Yeah.
Okay, so you can kind of see it here where in this data set, I have NA values for county, right? So again, going back to filter, the filter call on the beginning, going back to filter, what you want to do is your data frame with a truth condition, right? So in your case, what you want to say is, I want to filter the data frame such that none of the observations have NAs for a certain value, right? So how you would write that is to say, I have my data, I pipe it into filter, then I need to write my truth condition. Well, we know we can deal with NAs with is.NA or any NA. The thing with any NA is it doesn't tell you which one is the NA, so we will use is.NA here. So for example, here, if I say, okay, I want is.NA for county, I want the county values that are NAs, I want to take them out. I'll say filter is.NA county. Okay, what that gives me is all of these rows that have NAs in it. Because the truth condition is if it's NA, make it true. So if I want the opposite, I just need to negate this condition by adding an exclamation mark. And now I have a data frame that does not have NAs in the county, right? And you can double check this by putting it into any NA to look at county. Oh, wait, I think I did the call wrong. Let's see, how would I do this? County, put this into any NA. Okay, so what I'm doing here is this dot just means carry over the data frame, so I can do the selection operator on the column county. So by this point, I've selected the column county that supposedly doesn't have any NAs in it, and I put it into the function any NA to double check, and you can see it says false, which means there's no NAs in that column.
Is there a way to do it so that it's like, if you wanted to, if like say workshop had some NAs in it, and all the variables had NAs, but you wanted it for like county through GPA, you wanted to check, but since it's like, for me, like 80 variables, I don't want to type them one by one. Is there a way to say like column 2 ... column 4 or something like that?
So you still need to decide what variables you want to include or not, right? You still have to do that. So, I mean, in a sense, you need to determine like what are the ones that you want, right? Like, unless you want to specify every single variable to check whether they're NAs, you sort of have to do them. You have to specify them individually.
Okay.
Yeah.
I think the way I ended up doing it was like I created a variable that just added them all together, and then any of those that was NA, I got rid of the row. But I was just wondering if there was a quicker way to do it. But it doesn't seem like there's an easy way. It's like a weird, complicated problem. I feel like, I don't know. Yeah. But
yeah. So
yeah.
I mean, if you can specify how, like, what are the variables you want to filter by, right? Say all I want is to filter by county, social, cohort, GPA, but imagine this is like 80 variables where you can multiply this by like, I don't know, 10, right? Then what you can say is I can call variable names of data. I typed it wrong. Variable names of data. Okay, so I have all these things, and then I have to sort of like pick and choose what I wanted. Say I want these 4, right? And this is a very raw way of doing it, but without like an actual example, it's really hard for me to tell you exactly what you can do, even though it's very doable. Oh, sorry, when you do variable names data, it actually gives you a vector. So I can do, okay, so let's say this. So say I want to check every single variable that started with a C, okay? Then what I would do is to have variable.names, which gives me a vector. I need to make sure I save this as a selection vector, a vector, and I want these things I want them to start with a C, and I'll talk about strings after we finish tidyverse, but I want to see the variables that start with a C. So I have my pattern, regex, anchor C. Okay. what that gives me is a vector that has a false value for things that did not start with a C and a true value for things that did start with a C, right? Then I can then subset this data. I can subset this data with my selection vector. Oh, I forgot. I keep using the wrong name. Right, so I end up with these two. Now remember what we're doing now, even though we can see what's happening, these are supposed to be done as like a cohort. Or not cohort, what am I saying? These are supposed to be vectors. These are supposed to be vectors, right? So if I say vector S, if I save this thing into a vector S, okay, so now I have the vector S, which looks like this, and I said these are the ones I want to filter out. Then you can say data filter any NA in the vector S. Right. So what this is doing is it finds whether there's any NAs in these variables. So if you negate it, what am I doing? Oops, there we go. If I negate it, right? So this is one way for you to try to, oh, it didn't do what I wanted it to. Let's see. Filter metric condition. This is actually a great way. Oh, can you do that? Maybe you can, maybe you cannot. I'm not sure. Yeah, row-wise doesn't work. Yeah, I'm not sure. At the moment, I am not able to come up with the example that I can think through correctly.
Really? Can we do like filter isn't on all the data set, like on the whole data set?
Yes. The way to do that is a lot easier. You just do data is that NA data. I think this call works, or maybe it doesn't. Data is that NA data doesn't work. I know there's a way you can do it, but for some reason it's not coming up in my head right now. But you can. You can. Let's see. Yeah, I can't think of what to use right now. I know you can because I've done it before where I had to get rid of all the observation that have any NAs in it. I just can't think of it right now. Yeah, hold me to. I will figure it out. Hold me to that promise next time we meet. All right. Anything else? All right. Cool. So let's get into tidyr, and this is getting close to the end of tidyverse itself. Tidyr is pretty useful if you're just like managing a data frame, changing how it looks like. It doesn't really do all the manipulation that dplyr was doing. It's a different form of manipulation. So the first function I want to talk about is separate. Literally, separates a column into multiple columns. So what you would do is you put in data, you say, all right, I want you to separate this column, and I want it to be separated into these columns, right? So the column to separate into, so the new column names, and you need to tell R what you use to separate the column by, right? In the case of county, since I want to split it between county and state, I tell R the separator is comma space, so it separates, so I have counties in one column and then states in the other column. Right, so you can see that here where I have data separate county into county state by comma. Right, so I get counties and I get states. Now the flip side of separate, or the dual of separate, is unite. Unite is the same way, or except the opposite way, I guess. So in unite, you put in your data frame, you tell you what you want your new column to be called. Remember, you have to like give it this like kind of like a target column. In separate, you target the column you want to separate. In unite, you target the column that you want to get to. And then you tell tidyverse, or you tell unite what columns you want to use to put things together, and what you want to use as a separator. So what that does is I say I want to create a new column called new. I want to unite the column workshop and the column social. So you can see here I end up with no social or workshop, but I got this new column and is combined for social and workshop. That's unite. Make sense? Okay. Now the next two tidyverse or tidyr functions are gather and spread. We talked about gather and spread more extensively last week. So if you want, you go back to look at that. But to just kind of review it, you always do gather, you have a key value, you have a key and you have a value, right? So they're like the target column and what are the columns you want to use kind of idea. And this is how you transform your data, either from long to wide or wide to long. So gather is wide and you gather it to long. Spread is you take a long and you spread it to wide. There are updated or more recent functions still also inside tidyverse called pivot longer and pivot wider. They give you a lot more autonomy on how exactly you want to do this transformation. I have not needed to do that in my life, so I haven't learned how to use pivot longer and pivot wider. If you're interested, you can look it up and try to use it. But I think for most of my purposes and maybe most of your purposes in social sciences, gather and spread is good enough for you to use. But if you personally find gather and spread hard to use, go ahead and look at pivot longer, pivot wider, see whether that makes more sense to you. All right, so that's the end of the tidyverse part of the workshop. I gave another homework this time for tidyverse. It is also really, really long, but if you can successfully do this homework, you can do about 90–95% of data manipulation in R. You can do most of the things that you want to do. We'll again use the ACS data set that I gave last time. And you can just go through this problem on your own. I will warn you, it is fairly difficult. Like as I was writing it, every question targets a very specific part of tidyverse. It's fairly difficult and it requires you to think a lot about data. So it's going to be hard, but definitely think it through. That's what I would recommend. Then there's the second part of the data, which is homework, which is question 2. In this question, I'll walk you through how to simulate a data set. So remember like how I simulated this GPA, like that's how I did it. So you can, if you go through question 2, you'll learn how to simulate a data set and do more stuff with it. And also use some graphing. All right, so that's the end of tidyverse. And stop the recording now.